Okay, hello everyone, it's Salar and welcome back to this tutorial. In this tutorial, we want to find out how can we use OTP RTOS in STM32 Cube IDE. In previous part, I implemented printf function, okay? And I said you how you can use printf function to write string in the terminal by using of the RTOS. But in this part, I want to talk about thread priority. When you want to create a thread, one of our arguments is thread priority. But we can use these priorities to create a thread. In previous parts, I just used priority normal, but you can use other priorities. Priority ISR, priority real-time, high, above normal, normal, below normal, and low. Priority ISR is the highest priority level, and priority low is the lowest priority level. Okay, but the RTOS just runs those threads that have the highest priority, than others. Let's see an example. Here is an example. I want to create 6 threads. Thread 1, 2, 3, 4, 5, 6. And this is definition of the functions, thread functions. But I want to create thread 1 and thread 2 with priority high. Thread 3 and 4 with priority normal. Thread 5 and 6 with priority low. You can see that thread 1 and 2 have highest priority than others. And here is the implementation of thread functions. Thread function 1, 2, 3, 4, 5, and 6. Just we have a bodiless while loop in these thread functions. And I have one breakpoint on these lines, on while lines, in the start of while loops. Okay, but let's build the project and debug the project. The project has been created with no errors and no warnings. Now let's debug the code. Okay, now I'm in debug perspective. If I run my code step by step with step over, I can initialize the RTOS and create these threads. Now, if I want to run RTOS start, the RTOS will jump to the thread functions. Let's do another time, run the code. Jump to thread function 1, because thread function 1 is one of the threads that has the highest priority. Remove the breakpoint. Another time, run the code. The operating system jump to thread function 2. Okay? Another time, let's delete this breakpoint, and another time put the breakpoint here. Another time, if I run the code, the operating system another time jump to thread function 1, not other thread functions. But let's delete this breakpoint, delete breakpoint from thread function 1 and run the code. The operating system doesn't jump to other thread functions. If I stop the running of the code, stop in one of these threads, 1 or 2. and doesn't run other threads. Okay? Doesn't jump to other threads and doesn't run these threads. Because the RTOS just runs those threads that have highest priority. At this time, thread 1 and thread 2 have highest priority than others. Okay, but if you wait a thread by using a thread wait function or thread wait system call, if you make a delay for a thread or if you wait a thread with higher priority, RTOS will be able to run another thread in ready list with lower priority. Let's see an example to describe this slide. Okay, now I have this example in this time. In this time, I have just two threads, thread 1 and thread 2. But thread 1 has priority high, but thread 2 has priority normal. Priority normal is lower than priority high. I have two thread function, one for each of them. Thread function 1 and thread function 2, but I've used thread wait here. Let's build the project. Project has been built with no error and debug the project. Okay, now I'm in debug mode. If I run my code, the operating system first jump to thread function 1. Print its priority high and wait thread function 1. But after waiting thread function 1, jump to thread 2. Because at this time, for 1000 milliseconds, for 1 second, thread 1 waited and RTOS can run thread 2. Okay, if you wait a thread with higher priority, RTOS will be able to run another thread in ready list with lower priority. If you didn't have other thread with higher priority. Okay? If all of thread with higher priority waited, the operating system can run another thread with lower priority than the highest priorities. Okay? Now let's delete these breakpoints and run the code. Now, another time, if I open the terminal, you can see here the results. The operating system run thread with higher priority, with priority high and normal. Okay? Because after printing this string, thread 1 will be waited by using a thread wait system call. Okay, in this way, you can use concept of priority in your real-time operating system, in your examples, in your programs, in your projects. Okay, thank you very much to see me and see you soon in the next part.